Welcome everybody to Euclid's proposition number 34. In this proposition we have that any parallelogram, if we divide that parallelogram by one of the diagonals, say BC, that the opposite sides in that parallelogram are going to be equal, the opposite angles are going to be equal, and that the diagonals divide the areas equally. So let's take a look and see why this is going to be true. Now, because this is a parallelogram, we have that line AB is going to be parallel to line CD. And we have that line CB is going to cross those as a transversal. And so what that means by our proposition 29 is that our angle ABC is going to be congruent to our angle DCB, being opposite interior angles. But now flipping that around, because we have parallel sides AC and DB, we also still have CB cutting those as transversals. And so once again, proposition 29 tells us that our opposite interior angles are going to be congruent. And so our angle BCA is going to be congruent to our angle CBD. Now, by our common notion that equals being added to equals are going to be equal, if we add the blue angles together with the green angles, what we have then is that our angles DCA are going to be congruent to our angles ABD, and so that those two opposite diagonal angles are going to be congruent. Now, because our blue angles are going to be congruent, and our green angles are going to be congruent, and our triangle ABC shares a side of CB with our triangle CDB, it means that our triangles are going to be congruent by our angle-side-angle congruence property. And so what this means is that our angles CAB and CDB are going to be congruent. Our sides in between the red angle and the green angle are going to be congruent, and so side AB has to be congruent to side CD. And likewise, our sides between the red angle and the blue angles have to be congruent, and so side AC has to be congruent to side BD. And so we have that our opposite sides are going to be congruent, our opposite angles are going to be congruent, and because our triangles are congruent, then the area and our two triangles make up our entire parallelogram, that the diagonal divides the area of our parallelogram into equal size pieces. So I hope you've enjoyed this proposition, and I'll see you guys in the next one. Take care.